Hello, welcome to 715. It's called What Are the Connections? And what we're going to be doing today is going from a graph to an equation. Today your team will develop methods for finding an equation from a graph. As you find ways to write equations based on a graph, you will build a deeper understanding of exponential functions. When you're working through these, think of these three questions. 1. What information do we have? 2. Can we use other representations to help us think about our equation? And 3. How can we be sure that our equation works? So what we're going to be doing today is I'm going to give you 6 graphs. And in those 6 graphs, what you're going to be doing is finding an equation for them. Now, each of your equations should be in the form y equals a times b to the power x. A reminder, a is our starting point or our y-intercept. That's our y-intercept as well. B, that's our rate of change. So that is how our graph is going to change each time. So A is our starting point or our y-intercept. B is the rate of change. So let's take a look at A together. I have a graph that looks like it goes through 5 and that the next point is at over 1 and up 2. Well, the first thing that I can think of here is that if I wanted to start my equation, y equals, I got to think first of my A, my starting point or my y-intercept. In this case, looks like my y-intercept or the line is going through the point 5 on the y-axis. The next thing I want to worry about is what my rate of change is. Now it looks like in this problem, if we were to go to point 1 or our next point, it looks like it goes over from 5, 1 and up 2. So it makes a right triangle there. Now, be careful because if we were doing a linear graph, this would be over 1 and up 2. We'd be going up 2 each time. But in this case, it's not a linear graph, it's an exponential graph. So what I'm going to want to do is figure out, okay, well, if I go over 1 and up 2, my next point would be at 1, 7. I know it started at 5, so now that I know that it started at 5 and went to 7, what I can do is, because I know that it only went over 1, what I can do is take 7 and divide that by 5 to see how much it went up by. If I do 7 divided by 5, I should get 1.4. So in this case, this graph is going up from one point to the next at a rate of 1.4. And then we'll have to the power x as the completion to our equation. So each time it goes up 1 point, it will go up 1.4. All right, let's take a look at B. B is facing in the opposite direction. It's curving down. The points that I see are -1 and 120, and then 0, 40. Is there anything about this graph right now that we could use in our equation? Well, I know my y-intercept right now. I have 0, 40. So my y-intercept then has to be 40. That's why I have made my A. Now, what do we have to know about a graph that curves downward before we can write the rate of change? There's a special thing about a graph that curves downward that is different than a graph that curves upward. A graph that curves downward has to have a rate of change between 0 and 1. So what I see is that I have the number 120 as the negative 1, and the number 40 as my next point. So what I'm going to do is I'm going to take that 120, divide that by 40, and I see that that equals 3. What that tells me is that 40 is 1/3 of 20. So if I wanted to go down from 120 to 40, I would have to multiply by 1/3. Then I just put my x here, so 1/3 to the power x. All right, looking at C. This is my equation for the graph C. Can you describe the steps that I would have taken to get y equals 7 times 2 to the power x? Perhaps your solution or steps to get to the solution may be a little different, but what I would do here is I would first notice where the starting point is or where the y-intercept is, and I see that's at 0, 7, so I know my a is going to be 7. The next thing I would do is I look at what I know, so I know I have a point at 0, 7, and I know I have a point at 3, 56. That tells me that between 0 and 3, the graph changed by changed and went from 7 to 56. So when I'm doing exponential, I know my rate of change means that I am multiplying. I'm multiplying instead of adding. So I have to think, okay, what can I multiply by 7 to get to 56? If I don't know how to do that, what I can do is take 56 and divide that by 7. I should get the number 8. Now here's where it gets a little bit tricky, is because I need to turn this 8 into a number that I can times by itself 3 times. So what I'm going to do is I'm going to take the cube root of 8. That would tell me what number I can multiply 3 times to get to 8. When I do the cube root of 8, I get the number 2. So here is where my 2 comes from. So if that's what you came up with, great. If you came up with something else that still works, that's just fine. All right, here is an equation that I found for problem D. Am I correct or am I incorrect with this equation? Why do you think I'm incorrect or correct in this equation? What would you change? What would you make it instead? Well, I see that in this problem, my y-intercept is 18, so I'm going to keep that for sure. Now, if I go over 5, it's still at 18. So it looks like I'm not changing anything. I stay at 18 the entire way. So I'm going to get rid of 2. I'm not multiplying each by 2. I have to think of a number that if I multiply it, it's going to stay the same. The only number that I know that will do that is 1. So here is the actual correct equation. All right, for problem E and F, I want you guys to try that on your own and see what you can come up with. If you have questions, please let me know. After you do E and F, I want you to go down here and I want you to create a learning log entry in which you describe methods for creating an exponential equation given a graph. Be sure to include examples to illustrate your reasoning and record your answer below. So you have all of this open space to record things about turning a graph into an equation. All right, good luck.